Today we will begin looking at something called stoichiometry, or more commonly known as chemical math. The first thing I will need to do is to define for you how the chemists count atoms, ions, and molecules. It's basically a chemist's dozen. It's called the mole. The mole is a number of atoms, ions, or molecules that you can actually, it can actually be large enough to see and handle. Remember, atoms are tiny, and so if I only have 10 of them, I'm probably not going to be able to see them. I have to have a lot of atoms in order to be able to see them. The mole is a way to count things. Just like a dozen has 12 things in it, one mole has a certain number of things in it. In fact, every mole contains 6.022 times 10 to the 23rd things. They could be dogs, they could be atoms, they could be molecules, they could be chimpanzees. Anything that has that many items contains one mole. That special number, 6.022 times 10 to the 23rd, is called Avogadro's number. Avogadro's number is symbolized as N sub A. Molar mass is the mass in grams numerically equal to the atomic weight of the element in grams. Hydrogen, as we saw from the periodic table before, has an atomic weight of 1.00794 grams. Those many grams, 1.00794 grams, contains 6.022 times 10 to the 23rd hydrogen atoms. Magnesium has a different atomic weight of 24.3050 grams. But guess what? That many grams contains 6.022 times 10 to the 23rd magnesium atoms. So here is this in a visual representation. If I have a mole of sulfur, iron, salt, potassium dichromate, or sugar, I would have the amounts shown in the beakers in the picture. Each one of those contains 1 mole, in the first case, of carbon atoms in the sugar case, and of aluminum atoms. If sulfur is shown, a mole of water would have that many. Everything will have 6.022 times 10 to the 23rd molecules, formula units, or atoms, or cats for that matter. So the mole makes using the periodic table quite convenient. On the periodic table, I know this one's a little bit fuzzy to see, but if you look at silver with an atomic number of 47 and an atomic weight of 107.9, every mole of silver atoms will have a mass of 107.9 grams, and it will contain 6.02 times 10 to the 23rd atoms of silver. Same thing for carbon and for sulfur, except the mass will be slightly different. It's exactly that mass that you read from the periodic table that tells you how many grams are in 1 mole. So, if I want to calculate the mass of a single magnesium atom in grams, I would have to follow the following steps. So I want to know the number of grams of magnesium. The mathematics is shown here. I'm going to use the 6.022 times 10 to the 23rd number as something called a conversion factor. 1 magnesium atom times the fact that there is 1 mole of magnesium atoms that contains 6.022 times 10 to the 23rd magnesium atoms. Now if you note here, magnesium atom right here would cancel out with magnesium atom right here. I'm left right now with moles of magnesium atoms, which I then multiply by the atomic weight of magnesium, which is 24.30 grams of magnesium in every mole of magnesium. And now I can cancel out moles of magnesium atoms with moles of magnesium atoms, and I'm left in a unit of grams of magnesium, which is what I was looking for in the first place. If I multiply the tops and multiply the bottom and then divide, I get 4.04 times 10 to the 23rd grams of magnesium. That is how much one single atom of magnesium weighs. Very, very small. Let's go the other way. How many atoms are there in 1.67 moles of magnesium? If I want to know the number of magnesium atoms and I'm given the 1.67 moles, that's where I will start. 1.67 moles of magnesium. The 6.022 times 10 to the 23rd magnesium atoms divided by a mole of magnesium, that's our conversion factor. Canceling those out tells me that there's 1 times 10 to the 24th magnesium atoms in 1.67 moles of magnesium. Okay, how many moles of magnesium are present in 73.4 grams of magnesium? The known initial starting place is with 73.4 grams. There are 73.4 grams of magnesium. 1 mole of magnesium atoms, as listed on the periodic chart, weighs 24.30 grams. And then if I cancel those grams, I'm left with moles, and that will be 3.02 moles of magnesium. Again, here is the periodic chart as we have seen before. Again, the groups across the top, 1 through 18, periods down this way, 1 through 7, the atomic numbers, and the atomic masses, which you now know represent 1 mole of each of those compounds. Now, if we're working with more than just an elemental compound, more than just magnesium, we have to have a way to add up the total number of atoms and the total number of moles in every compound. So, let's see. If I have propane, whose formula is C3H8, we know that I have 3 carbon atoms and 8 hydrogen atoms from our previous slides. If I have 3 carbons, and each carbon, in order to get a mole of carbon, it's 3 of, and there are 3 of them, and a mole of them has 12 as its mass, 12.01. And if I have 8 hydrogens, and every hydrogen has 1.01 for its mass, if I multiply the 3 by the 12 and the 8 by the 1, and put those numbers here, and add them together, that tells me something called the total molar mass. The total molar mass of propane is 44.1 AMU, or 44.11 grams of propane in every mole of propane. Same as we had here, 24.3 grams of magnesium per mole of magnesium atoms, or, back one more, 24.3 grams of magnesium per mole of magnesium atoms. But now I'm not just in atoms. Now I am in molecules of propane. This is for the total of the propane. So let's do this again. What if I want to know the molar mass of calcium nitrate? Now, you have to remember there's 1 calcium here. There's, in this parentheses, this is a polyatomic, as we talked about before. Inside that parentheses, inside the parentheses, there's 1 nitrogen and 3 oxygens. But I'm going to multiply outside of that by 2. So I now have 6 oxygens and I have 2 nitrogens. So when I do my additions, I have 1 calcium at 40.08 AMU, 2 nitrogens at 14.01 from the periodic chart, and 6 oxygens at 16. Multiply those together, add them up, and I get a total mass of a mole of calcium nitrate of 164.10. Just to review, 1 mole of anything contains 6.022 times 10 to the 23rd molecules. So if I have a mole of chlorine, and chlorine is about 35 grams on the chart, I have Cl2, that means I have 2 times that. I have 70 grams for chlorine in order to get 6.022 times 10 to the 23rd chlorine molecules. I have propane, just as we calculated, right here, 44.11 grams, which contains 1 mole of propane molecules. But if I want to look at the atoms, it contains 3 times that many atoms of carbon and 8 times as many atoms of hydrogen.